All right, so let's take a look at the answer key now on this electron configuration check. So I'm gonna go through this very deliberately and very slowly because we need this as review for the test or the makeup test, which is tomorrow. So the number of electrons that can occupy a 3D orbital. Now, this is any one individual orbital, really, whether it's a 2D, a one, a 1s, a 7f, any individual orbital can only hold 2 electrons. If you think about doing the orbital notation, and each box represents a particular orbital, how many can go in there? Well, the maximum is 2 in any individual orbital. Now, there are 5D orbitals. Well, if they can each have 2 electrons, that equals a total of 10 electrons. There are 3p orbitals, which could equal 6 electrons. There's only one s orbital, which would be 2 electrons. That's where those numbers come from. But each individual orbital can only hold 2. So we have to identify now this configuration. Well, the easiest way to do this is to look at the highest energy level. First of all, this is 4. So it's going to be in the fourth period or fourth line of the periodic table. And we see that it's going to be in that S block. And it has 2 electrons in the S block. So I'm going to go to my periodic table. Let's go to the fourth energy level. There's 1, 2, 3, 4. So it's got to be something on this line because it ends in the highest energy level of 4. Well, it's got to be over here in this block because it's in the S block. Well, that's S1. This is S2. So that has to be calcium. Now, this electron configuration is expressed a little bit differently, but we can still figure it out the same way. This is the shorthand or the noble gas configuration, where we don't write all the stuff on the inside. We start with the noble gas of the line before. So let's find argon. So here we are at argon. We're going to take argon and we're going to go to the next line. And we're going to be on this line now because argon is at the end of line 3. So we take argon and we add on some stuff for line 4. Well, what are we adding on? We're adding on S2, but then D6. So here we go. Here's 4S1, 4S2. Now we get into the D blocks. D1, D2, D3, D4, D5, D6. So that there is iron. Identify the element with this configuration. Well, we're in the second energy level and we're the P blocks and P number 5. So here we are. We know we're going to be over here because this is the P block over here. It's P5 in the 1, 2 energy levels. 1, 2, 3, 4, 5. So that is fluorine. And I spelled that wrong. The U comes first, but spelling, what the heck? Okay, what atom matches this electron configuration? It's the one that ends in 3D10. So we know we're going to go to the D block. That's going to be one of these guys here in the middle. And it's going to be the 3D, this is energy level 3, because remember for the D's, the energy level runs one level behind. It is D10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is zinc. What electron configuration matches an oxygen atom? Well, we can go to the periodic table. We can see oxygen should end with a 2. And it's in the P block. It should end with a P 1, 2, 3, 4. So do we have one here that ends in 2p4? We that one right there. All the rest of these have way too many electrons to be oxygen. This one's close, but this one's P6. P6 would be 2 more over from oxygen would be neon. Now, each row on the periodic table represents an energy level. As you go down a row on the periodic table, 1 energy level, 2 energy levels, 3 energy levels, 4 energy levels. Each row represents an energy level. There are 4 different types of subshells, or what we call orbitals, S, P, D, and F. That is true. Now we got a question here with this orbital notation. Which element is pictured? A couple ways we can do this. First of all, let's just count up the electrons. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 electrons. The only element that has 10 electrons is neon. Okay. We could have also done this by how it's arranged. It ends in 2s2 and then 2p6. So we go to the second energy level and we go to the p6, which is 1, 2, 3, 4, 5, 6. What is incorrect about this orbital diagram? Remember, we have 3p orbitals, and remember that electrons don't pair up until they have to. So that means that should be like that. In the 2p box, there should only be 1 electron in the first and then 1 in the second, because they don't have to pair up until they absolutely have to. That's our answer. Now, how many electrons can be placed in the p orbitals? Remember, there are 3p orbitals, 2 electrons each. The total then is 6. Which of the following has an electron configuration that ends in an S? So we've got to find the one that's on the S block of the periodic table. Well, neon. Neon doesn't end in S, it ends in P. It's over here in the P block. No good. Sulfur. Sulfur's over here. It's also in the P block. So it's not sulfur. Boron. It's also in the P block. Well, I'm thinking pretty strongly it's calcium, and sure enough, calcium's over here in this S block. So what's the purpose of the electron configuration? All it does is shows us how the electrons are arranged in an atom, how they are spaced out or arranged around the nucleus. That's what it does. So all orbitals of an energy level are occupied by 1 electron before they are paired up. That's all that's saying. That was just like we did in the previous question. We don't put another one here. We unpair them, and we don't pair them up until we have to. That's called Hund's rule. They don't pair up until they have to. And finally here, we got this Bohr model of an atom. And we want to know how many valence electrons are present here. You have to understand that valence electrons are last energy level electrons. Well, that's this outermost ring. Well, let's count. 1, 2. We've got 3 valence electrons for this particular atom. We could also tell what atom this is, because we see it has 1, 2, 3 energy levels, has 3 valence electrons. We could find from the periodic table, 3rd energy level, 3 valence electrons. That's aluminum. Okay. So once again, this is a very good indication of what you're going to be expected to do on the makeup test tomorrow. If you have any questions about these problems or anything in general that you need some assistance with, need some extra practice, make sure to email me or reach out to me via Teams. This is probably the better way to get in touch with me, because I'm always on my email. I'm not always logged into Teams, especially after hours.